Okay, hello everyone. This is Volts for July 18th, 2025. What's going on with electric boats? I'm your host, David Roberts. Cars get all the attention, but there are plenty of other types of vehicles for which electrification makes as much or more sense. One example, boats. Most boats leave from and return to the same place every day, so they have a natural spot for charging and fewer range worries. As anyone who has driven an EV knows, electric motors have crazy torque, so they accelerate quickly, which makes a difference when you're dragging people around a lake. Also, anyone familiar with lake sports knows that gas and diesel engines are extremely loud. It is impossible to have a conversation if you're going more than 5 or 10 miles an hour. Electric motors can be much quieter. Also, they don't spew toxic fumes in the faces of swimmers and wakeboarders. It just makes sense. Several companies have jumped into the electric boat game, seemingly more every day. The one that has gotten the most attention is ARC, a VC-backed team of rocket scientists, or at least rocket engineers, that have designed and manufactured a high-end wake sports boat, the ARC Sport. A fishing boat, the ARC Coast, will be available next year. The boats are nice, but they are expensive. Let's get into it. I'm excited today to have with me Mitch Lee, the co-founder and CEO of ARC, to talk all about electric boats, the design challenges, the economic logic, the performance advantages, how he plans to bring down costs, and just how much of the marine sector can be electrified. With no further ado, Mitch Lee, welcome to Volts. Thank you so much for coming.
Thank you for having me. I'm excited to share more about what we're doing at ARC and the mission that we're on.
So let's go back to the very beginning. 4 or 5 years ago, I think. You had been in software for a while. I think you sold your software business. Your friend Ryan was designing rockets for SpaceX. And you guys were thinking, hey, let's start a company. And you looked around and you settled on electric boats. So I'm just curious, what went into that? I'm sure there was some market analysis. I'm sure a little bit of it was following your heart. I'm sure some of it was sustainability. What was the mix?
Yeah, it breaks down to 3 things. The first is that ARC is a pursuit of personal passion. I grew up in the Bay Area to parents that loved being out on the water and had our family out on the water all the time. A lot of that was skiing behind our 1986 Mastercraft Postar, where I learned how to kneeboard, wakeboard, double ski, slalom ski, you name it. But we also spent a bunch of time out there on the river fishing and generally just enjoying the water. Fast forward, I get a degree in mechanical engineering. I spend a while as a mechanical engineer. I then pivot over to software and jump around some software startups, including starting one of my own that was later acquired. At that point, I started thinking about what do I want to go do with my career in this next phase? And I had always had this idea, as I'm sure a million other people in the US have had, that electric boats make a lot of sense.
Right? As I said, it seems like it's just sitting right there.
It's one of those very obvious ideas that is dominated by execution risk rather than market risk or technology risk. I mean, electric boats just make way more sense than gas boats. You could talk to somebody driving an F-350 and they'd still say, yeah, electric boats make more sense because gas boats are a nightmare to maintain, a nightmare to keep running reliably. They're super expensive to operate. They're loud. You can't hear yourself think, much less hear the person surfing behind you.
I mean, they're sort of legendarily a misery to own, right? There's a whole kind of mythology around it.
Absolutely. There are all these phrases in the industry, like the best days of a boat owner's life are the day they buy it and the day they sell it.
Yes. Yes.
I really think the analogy to automotive undersells the opportunity because gas cars are pretty good at what they do. They are quiet, they're reliable, they're fuel efficient, they're inexpensive. They are the benefactors of 100 years of these giant automotive companies pouring money into R&D and refining that machine. That is not the marine industry today.
There are companies out there doing this, and there have been for a good while. What did you so when you looked out at the market, what did you find lacking?
The way that the industry has evolved looks different than automotive. Pretty much anyone can make a boat. You have hobbyists that make boats in their garages and kind of strap on an outboard, and you have yourself a boat.
Right. I guess there's not the same legal hurdles to get it, out on the road or out on the water, I guess.
Exactly. So it's a low barrier to entry. And what that ends up translating to is a lot of different boat builders out there. You almost get this commodity market where a lot of people are using the same sorts of outboards with the same sorts of motors, the same sorts of components off the shelf. And what that means is that in a commodity market like that, or a market that's differentiated largely by brand rather than technology,
right,
you don't have a lot of spare money to pour back into R&D to, make all of this stuff better. What happened in the past, call it 8 years or so, is that there's been a paradigm shift. Something that was not previously possible is now possible thanks to the automotive industry. So the automotive industry has been reaching incredible scale with the electrification of cars. And that has established supply chains for things like batteries and high voltage, power electronics and all the different things that you need to go make an electric vehicle possible. You can, in some respects, buy off the shelf. Now, there's a giant asterisk around that, but the supply chains now exist that as a boat company, you don't necessarily need to go pour tens of millions of dollars into R&D to get a product to market.
I see. So you're drafting a little bit off automotive
Exactly.
spending on innovation.
Exactly. So going back to, how did we end up at ARC? Well, one was the personal passion. It's kind of this obvious idea that I personally feel a lot of passion for. The other is a compelling mission. Even setting aside, global warming. Gas boats are, most people can agree that you don't want fuel getting dumped into the water. You probably don't want black carbon burning in our ports.
I mean, and there are specifically people breathing in very close proximity to these, all these things.
Every gas boat comes with a sticker on the back that warns about carbon monoxide poisoning. And, you've got kids on your boat. So I think that there's a lot to like about the mission side of this. Mm-hmm. And then the execution part is maybe the most compelling and maybe what tipped myself and Ryan, my co-founder, into doing ARC. The technology was there thanks to the automotive industry. And the hard part was actually putting it all together into a product. And that's where a lot of his expertise comes into play, that, he had worked at SpaceX building complex products there and had a network of other super talented engineers that he could tap into when it came to helping build ARC. So when we looked at it, we're like, all right, compelling product, it's a compelling mission, the timing is right, and the hard part is figuring out how to actually get these pieces to fit together in a way that's competitive with what's already in the market. So our job is fundamentally to solve the power challenge. How do you build battery packs that are big enough to sustain the amount of power that boats need moving through water, which is 1,000 times more dense than air? Then how do you bring the cost of those packs down low enough to be price competitive? How do you compensate for the weight and the size of the packs? And, how do you prepare them?
Is it safe to say that you are the first company to just sit down with a blank sheet of paper as opposed to trying to sort of electrify current offerings and current technology?
I don't know that we're the first. I think many people have experimented with this. I think we have taken it the furthest.
I'm very curious, when you sit down with a blank sheet of paper, you're going to design a boat, you're going to design an electric boat. I'm guessing that design consideration number one is the battery. It's big, it's heavy. So the physics of it and the layout of it, how did you think about the relationship of the battery to the vessel as a whole, to the hull? What were those design considerations around the battery?
Yeah, pretty much everything about ARC you can derive from the basic premise of we're solving the power problem in maritime. That in order to go electric, you need to overcome the fact that boats consume a lot of power moving through water. So the natural consequence there is you need to store a lot of energy on board, which means big battery packs.
Right.
That was definitely where we started. And then that creates second order problems. You can't just buy a big battery pack off the shelf. So you need the team that can go a level deeper to be able to build those size of battery packs in-house.
So your battery pack is 226 kilowatt hours. Just to help listeners out, like how does that compare with a car battery? Like what is the...
Yeah, you could think of it being roughly 3 times the size of an electric sedan.
No shit. Oh, pardon my French. Really? 3 times bigger than an auto battery. And auto batteries are big.
Right. And boats consume a lot of power. I mean, boats are closer to semi-trucks than they are to sedans.
That's really interesting. So that really is a design problem then. A 226 kilowatt hour battery, 3 times the size of a car battery. You have to integrate that into the vehicle.
Yeah, so that brings you to one of the problems, which is, okay, that thing is big. It's heavy. It's expensive. How do you compensate for those things? Well, it really boils down to you need to build the vessel around the battery pack. You need to integrate these things intelligently. In the same way, if you look back at the early automotive industry, electric cars didn't get that compelling until Tesla came along and built the car around the battery pack. And suddenly you get the frunk and you get the low center of gravity and the great cornering, and you get all these other benefits by rethinking the vehicle around the electric powertrain. We're doing that same thing at ARC for boats.
So for a normal boat, the engine is in the back. That's the big chunk of weight, I'm assuming. Like, where is the battery in the boat? How should we think of the layout of the battery?
It depends on the product, and it looks different on every product. You know, our Wakesport boat has the battery positioned differently than our center console boat, which has the battery positioned differently than that luxury cruiser that we started with, the Arc One.
And this is all going to depend on how the boat is intended to move around.
Exactly. And the purpose of it. So the Arc One had a unique layout to it. It was very spacious for the size of boat that it had because everything packaged below the floor. In those cases, it was 2 flat packs, a total battery capacity of 220 kilowatt hours, and everything packaged below the floor. The battery packs were actually structural to the boat, so they were supporting the floor directly. In the Arc Sport, your goal is throw an incredible wake. And so the battery pack position shifts, and it's actually a single pack that's 226 kilowatt hours, and it's located near the back of the boat. And in the Arc Coast, you're going for range, and how much distance can you cover, and that battery pack shifts forward a little bit. Also because of the motor position on the boat, that on the Arc Coast, it shifts to the back of the boat, whereas on the Arc Sport, the motor's located further forward. So it's all to say that we are building the vessels around the electric powertrain and optimizing them for what their purpose is.
One of the actually more recent Tesla innovations is literally integrating the battery pack into the frame of the vehicle, such that like it is, as you say, load bearing, like part of the frame of the vehicle, which, you know, people have debated about this, gets you efficiency, right? Gets you more out of your battery, but it also means you can't swap out the battery. The battery is not very like sort of modular or replaceable or recyclable, et cetera. Like, are you thinking about those considerations? Like how integrated is integrated?
What Tesla is doing in the industry is special. They have accumulated intellectual property over a long period of time that allows them to push the limits of what electrification looks like in a vehicle. And they operate at a scale where those marginal benefits make a lot of sense to invest in. For us, we are not actually trying to push the limits of where the industry is at today from an electrification perspective. So we are happy to be downstream of automotive R&D. Say, look, we're going to do something that we know works. It's a proven formula. And how do we make this as serviceable or maintainable as possible for us and for our customers, which involves, you know, not directly integrating cells into the structure.
So you can switch if the battery, like theoretically, if one of these things are driven around for whatever, 10 years, I don't know what the warranty on a battery is, you can replace the battery?
You can. I will immediately volunteer that we do not expect anyone to be constrained by battery cycles. What I mean by that is automotive, these battery packs are designed for, say, 5 years or 10,000 cycles, 5,000 cycles, which you might hit if you're driving your car 360 days a year. Boats are used less frequently. And so your useful life on the battery pack before you see some amount of degradation is so much longer in terms of calendar years.
I want to get back to the battery, but the hull, the Arc Sport hull is aluminum.
It's actually composite.
Composite. Is that different than the industry standard in some way that is related to this design challenge?
Yes. So when we started with the Arc 1, we made it out of aluminum. And that really supported our ability to make modifications to the hull as we went. It was conducive to the R&D process. As our ability to design hulls matured, we have switched over to composite because that's where the industry is at today, and there are many benefits to that. However, we use a different form of composites. So a lot of boat builders today in the sport industry, and everything I say is specific to the specific segment that we're in. So if you look at wake sport boats, most boats are made out of chop sprayed fiberglass. It's a low skill form of manufacturing that involves basically taking fiber, putting it in a blender with some resin, blending it up and spraying it out. The downside is that it's bad for the people doing it, it's bad for the environment, and it has pretty bad material qualities. But again, it's cheap. What we have switched over to is, if you think about what are we trying to accomplish, well, we've got this big, heavy battery pack, and we need to compensate for the weight of that battery pack somehow. The way that we're doing that is by taking weight out of the hull and giving that back to the battery pack. So we want our hull to be stronger and lighter than boats that exist in the industry today because we have this big battery pack.
Right.
The way that we do that is by using vacuum resin infusion. So it's still a fiberglass hull, but it is using a different manufacturing technique that allows us to get a lot more strength for a given unit of weight.
Interesting. And I'm curious, like with the lighter hull, do you net out at a comparable weight to other boats in this category?
That's the goal. We are a little heavy relative to other boats of this size. We're certainly within the realm of what wake sport boats weigh. But if you look at another 23-foot wake sport boat, will be a little heavier than that. However, that is not necessarily a bad thing. Everyone in this industry wants to have a heavy boat because it's what displaces water and allows you to throw a great wake. So in a lot of respects, that's actually an advantage.
So the weight, you don't have to be as worried about weight as you would with, I don't know, like a rocket for SpaceX or something like that. Like
Correct.
A little extra weight is not that big of a deal.
We still want to get close because of trailering loads. So
Right.
you want to be able to use the truck that you already have.
Right.
But outside of that, you're not really concerned with weight, especially when you consider how much power we pack into the boat, that you don't really feel the weight. It still handles like a jet boat because of the amount of torque that we have, the amount of power that we have.
What is the battery chemistry?
We use NMC.
Right. Kind of old school. Is that just the most power dense? Is that for power density?
Right, exactly. So there are a variety of trade-offs here. And one thing that I will call out, kind of harkening back to, Tesla's making certain design decisions. Those design decisions are optimized for automotive. And we are making a different set of design decisions that are very much optimized for the marine industry, for how boats are used. An example, we are not cycle constrained. So trading to chemistry that gets you a much higher cycle count doesn't actually benefit us.
Right, which is LFP, just to throw that in there. It's trading to LFP gets you lower density, lower power density, but more cycles, but you don't need more cycles.
Exactly. That's a good example. Some of the things that automotive is really sensitive to, like cooling, we are less sensitive to, because automotive has this challenge of your car has a very high peak power, meaning when you are accelerating onto the highway, you are consuming a lot of power over a short period of time. And relative to the size of your battery pack, this is known as the C rate, that power consumption is significant relative to the size of your battery pack, and that can really heat things up. On a boat, it's actually quite hard to have a high peak power because you're limited by your propeller. The propeller can only put so much power into the water. So you can think of a propeller kind of like a tire, and a boat has basically a really bad tire on it because...
Yeah, I was going to ask this later. Like, would there be any point at getting more powerful battery at a certain point? Because I feel like you're limited by other physical things. The amount of you can accelerate in a boat is not unlimited, even if you had...
Exactly. You start being limited by your propeller. Now, we could increase the size of the propeller, and we have, but you are still bumping up against the limits of...
Well, like physical comfort at a certain point is scaring the crap out of your out of your passengers at a certain point.
Right.
So, everybody wants to know also, I mean, NMC is in the flammable category of battery. And it's funny. Everybody, the first thing they want to know when they hear the term electric boats is about safety. I'm sure at this point you've heard all the Trump jokes. You've heard the Trump getting shocked versus sharks. I'm assuming that if for whatever catastrophic reason you hit a rock and were sinking, that you would not get electrified by this boat, but just by say a word about like, it is electricity out in water. So how do you think about that safety?
I have many different ways to answer this. I will start by saying cars also get wet. So a car goes through a car wash, they go through rainstorms, they ford rivers. And the automotive industry has already kind of developed the technology necessary to waterproof these battery packs. And they need to be waterproofed. Our boat batteries are not sitting in water. In fact, they're sitting quite far off of the water. They're, feet above the bottom of the hole where water might collect. So we're already leveraging technology that exists. And then we take that several steps further. We put a lot more emphasis on the sealing of our battery packs to make sure that they are... we essentially strive to be IP67 rated, which means you could submerge a battery pack under a meter of water for 30 minutes and it not leak. And that's kind of an insane standard for a battery pack of this size. That's like a lot of water pressure on it.
Yes.
So we take that obviously several steps further, and then we think about redundancy at every level. It's like, okay, now let's assume that our IP67 battery is not... has some sort of leak in it. How long can you go before it becomes an actual issue? And so we do a bunch of testing on that. And the way we've designed the battery pack is tolerant to water sloshing around on the inside of that pack. We have sensors that are monitoring for all of this and alert you. And, the analogy I would draw here is like in cars, the safety, you should definitely be concerned about that. You could get in an accident, you could be immobilized, and like you definitely want time to be rescued. On a boat, if you crash that boat and it's sinking, you put on a life jacket, you are good to go.
You're not hanging out on the boat for long.
Right. It's unlikely that boats are inherently pretty safe in part because you can control your own safety by putting on a life jacket and exiting the boat. You're not going, insane speeds or anything like that.
So there's no sort of like wreck or accident you could envision that would be traumatic enough to the hull to make electricity and water a problem.
Not where the battery pack is positioned. Now, you could hit a rock and sink your boat, and eventually that battery pack will go underwater. That is true.
Right.
But the thing, we just talked about electric vehicle safety. I want to take a second to talk about gas vehicle safety, which is very bad. So gas boats are pretty notorious for catching fire because one of the biggest problems that you have is you have this hole, which is a big pocket of air. And when you run that engine, it creates fumes. And if you don't blow those fumes out, and then you go ignite the engine, it can cause a fire. The engines are also not typically designed to run at very high continuous power, which is what boats generally do, and can catch fire, like overheat. So you end up with a status quo of gas boats catching fire more often than most people think. If you have spent enough time at a marina, you have seen a boat catch fire. Electric boats are much safer than that. And so you are starting out from a way better place than you are with your gas boat in terms of safety. We've got a ton of sensors on board to warn you if there's any sort of anomaly with the vehicle. Gas boats do not have that.
Interesting. And what about charging? I mean, one of the things I think that's relevant here, and that's sort of like, sort of obvious once people are reminded of it, but they don't necessarily think of, which is that there are electricity. There's batteries on almost all boats these days, on almost all modern boats. So like electricity on boats is not a novel
Exactly.
problem. And similarly, because there are batteries on almost all modern boats, there's charging available on many modern docks and marinas. But I'm sort of curious, like, how many boats go electric before you max that out? Do you know what I mean? Like, how prepared is marine infrastructure for electrification at scale? Hey there, everybody. Don't worry, I'm not going to tell you about a new mattress or push a credit card on you. This isn't an ad. There are no ads on Volts. It is supported entirely by listeners like you. If you'll indulge me for a second, I'd like to ask for your support. I started Volts because we're all surrounded by depressing news about climate change and misinformation about clean energy, and it's never been more important to share the stories of the real people on the ground doing the real work of transition, and all the ingenuity and courage and public spirit they are bringing to it. People are hungry to hear these stories, to learn from and find inspiration in them. I've heard from people who changed majors or careers after hearing episodes of Volts, people using it in classrooms and community groups, even state legislators who have passed bills inspired by specific episodes. Sharing these stories matters. It makes a difference. If you have found value in it and want to help me continue doing it, I hope you will join the community of paid subscribers at volts.wtf. It's about the cost of a cup of coffee a month. If you don't like subscriptions, you can make a one-time contribution, leave a review on Apple or Spotify, or just tell a friend about Volts. I am grateful for any and all support. If you're already a paid subscriber, thank you. And now, back to the show. How prepared is marine infrastructure for electrification at scale?
This is one of those areas where the more you dig into this idea, the more obvious it becomes. I will argue that gas boats make way more sense to go electric than gas cars. I'm glad that cars have gone electric, but when you look at the opportunity or the percent improvement in your experience, it is dramatically higher in going from gas boat to electric boat.
I should have said this earlier. My parents co-owned, we were sort of like classic lower middle class Tennessee. We co-owned a boat that we parked at this lake. Tennessee's full of lakes. And so I can testify on a personal basis that gassing up a boat is an unpleasant experience.
Right.
Gassing up a car is unpleasant, but gassing up a boat is even more unpleasant.
Yeah, a lot of people lug gas cans down to the dock, or they've got to go 30 minutes to the one marina on that dock, or trailer through a gas station. There aren't great solutions out there compared to plugging your boat in and every morning it is ready to go. So to get back to your question about infrastructure, the awesome part about boats, take the wake sport boats that we're producing today. A big day out on the water might be 3, maybe 5 hours. Mm-hmm. Call it 4 to 6 to be conservative. That means that you have 18 to 20 hours to recharge before you're using that again.
Yeah.
Which means that level 2 charging, which most marinas already have, you could easily get down to your dock. If you already have a boat lift, then that runs 240. The infrastructure is a very tractable problem here. It's not doing anything crazy there. So they are already wired for this sort of power, and you charge it overnight, and the next morning it is ready to go. And when you take it out on the water, you have perfect precision over how much battery you have left. So range anxiety is solved.
Yeah, I wanted to ask about range. And then as I was thinking about it, I was like, well, is that really people do not take out their boat intending to go far generally, or like, you know what I mean? Like that's generally not the purpose. Sort of like, what is the right unit? What units do you use when you're telling people about the capacity of the battery, what they can expect from it? What are the right units here?
So we tailor it to the market. And for the wake sport market that we're in today, we say 4 to 6 hours of active usage time. I have grown up on wake sport boats my whole life. I could not tell you their range in miles because that's not how you use the boat. You take it out, you basically go in circles. And then you bring it back. 4 to 6 hours is the target there. The reason that it's hard to even estimate, more precisely than that is it very much depends on how you use the boat. So at low speeds, you are consuming almost no power. At 5 miles an hour, you could go for tens of hours, well in excess of, call it 200 miles. You would have a really hard time running out of battery at low speeds. At high speeds, you consume a lot of power because power draw starts to go cubic once you're up on top of the water, cubic with your speed. So 40 miles an hour is very consumptive. What that means, though, is if you think about the typical wake sport profile, you go through a no wake zone at 5 miles an hour, that burns no battery. You put somebody in the water, they go surf for 30 seconds, they fall because they were trying to trick. You go pick them back up, you're at 5 miles an hour again, not consuming battery. You go do that a handful of times, you stop for lunch, again, not consuming battery. And when you blend these things together, what you realize is actually a lot of time out on the water is with the boat not necessarily in motion, or at least at slow speeds. And that translates into unexpectedly high amounts of time you could be out there before running out of battery.
But there's no real, you can't sort of guarantee anything just because usage is so variable that the amount of time one boat could be on the water.
We have collected a lot of data on this. So we collect data from all of our own boats. Each of our boats is streaming thousands of data points a second that we can then run analytics against. We've also gone and looked at diagnostic data from typical wake sport boat gas engines that we've pulled off and have looked at, we've done data logging exercises where we put little data loggers on boats to really understand the amount of time people tend to spend at different speeds. And that is what allowed us to size the battery pack. Now, when we sized the battery pack, we wanted to make sure that we met the needs of the majority of the market without oversizing it, because then you're paying for battery that you're never going to use. It's kind of like if you think about your phone, you don't want your phone battery to just get bigger and bigger and bigger because now you're carrying around something that's heavier. You don't really need it. All you need it to do is last you through the day. You're going to plug it in overnight and, it's good to go again.
So the idea here is you can say confidently you're not going to run out of battery if you go out for the day, basically.
Yes, that's the goal. Full day of usage is the goal.
Right.
The thing that I will say with confidence is you will not get stranded because you ran out of battery. This is a really compelling point that I hope resonates with people that have been stranded on gas boats, myself included. You could go straight offshore at top speed, run the battery down to 5%, turn around and make it all the way back. Because at low speeds, you're consuming so little power. Exactly. So the boat actually essentially safes itself and says, if you get low enough, you can only draw a low amount of power and you will make it back to shore. It's not a question of if you make it back to shore, it's how long it takes you. You'd be pretty annoyed because you would have covered a lot of distance and now have to go back at slow speeds, but you will make it back.
But sort of this mental image of running out of battery and being stranded in the water effectively it cannot happen.
Correct.
That is an interesting point. It's not really totally analogous to a car, right? There are differences.
Well, because in a car, you can't really go, you can't be on a highway going
right, exactly.
2 miles an hour.
Exactly. Did you guys mess with the motor at all? Or did you just buy a big motor off the shelf?
Our goal is to use as many components off the shelf as we can, because what you get by doing that is reliability and certainty around the performance profile. There are cases where we have had to make modifications to off-the-shelf parts or bring something entirely in-house. The motor is an example of something actually on the Arc 1 that we had to modify to suit our needs because the motors run at such high continuous power that they need extra cooling that they might not otherwise need. We solved that problem so that we could use an off-the-shelf automotive motor for the Arc Sport. And we're happy with the result. That motor is, knock on wood, bulletproof. It's over-designed for the vessel, and we're happy about it.
Yeah, 425 kilowatts for anyone out there who's listening and cares. So, just in terms of the experience, I mean, you've referenced this a couple of times, but anybody who's driven an electric car, I think almost universally finds like, whoa, this rules because it's so peppy. Like I have a Chevy Bolt, which is, the dumpy hatchback version of the EV world. And it is the zippiest, fastest off the line car I've ever driven in my life. Is the difference in performance as striking with an electric boat?
It is as striking, but in different ways. So it is exciting to punch the throttle for two reasons. The first is the responsiveness is so much higher. Imagine going from an old gas Suburban where you punch the pedal and you have to wait for the car to realize you did compared to your electric car where it's responsive. Like that's a really great feeling as a driver. And it does launch in the way that we have a bunch of torque from our motor, and we've paired it with a larger than average propeller, which means that you can dump more of that power into the water. So you definitely do feel that exhilarating punch when you hit the throttle. It's not as extreme as you might see going from, I don't know, like a Honda Civic over to Model S, because we're limited by the propeller. But it is way more striking in other ways. The most notable one is how quiet it is.
Yes.
Gas cars you are in a shell, and they do a really good job of dampening sound. So it's quiet, and you could hop in a Mercedes and it's whisper quiet in there. Gas boats are the exact opposite. There is nothing kind of covering you. There's no sound dampening, and it is deafening. So as soon as that boat's in motion, all that you could hear is the engine. You are yelling at each other to talk, or most often you just stop conversation while the boat's in motion and you resume it when it stops. The experience of being on a boat, even just going 5 miles an hour, and all you hear is the water is incredible and striking and leaves people with this imprint of what boating should be like.
Maintenance, I'm guessing, similar to EV, similar to cars, is much less simply because there are fewer moving parts.
I'd say even better.
You're not controlling thousands of explosions every second.
Yeah.
Is that a bigger difference than in the automotive world?
It's a bigger difference than in automotive because your electric sedan still has windshield wipers, still has actuating trunk, still has lights, like all these other components that can break the AC unit. And, when you strip away the complexity of a combustion engine from a boat, you are left with a very simple vehicle. There's not a lot else going on outside of the complexity of that motor. And you're in a highly corrosive environment, water, that really does damage when you've got thousands of little parts on an engine. When you then, seal this all in a battery pack and it's just a very simple structure, your maintenance burden goes down by quite a lot.
And is there any concern sometimes you hear like you don't want to leave a battery half charged for long periods of time. Boats are all going to be parked for long periods of time. Is there any worry about battery degradation or battery quality, or is there any problem with storing these for a long period of time?
No, is the short answer. Ideally, you leave the boat plugged in if it's in storage for a long period of time. The software, the firmware will handle the rest for you. The reality is a lot of that talk is optimization on the margin, where you're dealing with a vehicle or a device, think about your phone or your laptop, that gets cycled so much that becomes a concern. How do you extend that? Again, you go back to boats, they're just not cycled that much. So you don't have that same sensitivity to how do you eke out that next 10 or 100 cycles from it? Yeah, it's just not the same concern that you have in these other industries or applications.
And so maintenance is less, but one other maintenance question is, are there people who know how to fix these things? I mean, if something does go wrong, is there the knowledge out there yet? Can you call a mechanic and he'll be able to work on this? I'm just curious, from the mechanic's perspective.
Right.
How much is left for them to do and how unfamiliar will it be? What's the deal there?
We are still building boats, and there are still very basic boat parts on these boats. If you ding a prop, anyone can go help you replace that. If you tear upholstery, there are upholstery people all over the country. If you scratch your paint or your gel coat, there are people that can fix that. That's kind of that first tier and the most likely type of maintenance that you will run into. People are familiar with that today. The next level down are things that we could fix with software. We have the ability to update our boats over the air, and we do so regularly. And you can solve a surprising number of things through software when you have a boat that is primarily driven by software. It's throttle by wire, it's steer by wire, it's all controlled by a PCBA, like a compute engine on board.
So you could fix problems over the air, theoretically?
Yes, absolutely. And we have.
Interesting. Can you add functionality over the air? Sorry, we're off the maintenance thing for a bit, but like the over the air thing has captured me. Can you add new features and functionalities like Tesla sometimes says they do?
Absolutely. We have been doing this at a steady clip. Some might even call it a frenetic clip over the past year, that every week or two, the boat's getting better. It's getting smarter. It has new functionality, new features. And that's not just about updating what the touchscreen display looks like. It's giving you more advanced control over the thrusters that are on board, giving you different steering profiles, different throttle profiles, the ability to record surfers and play that video back, the ability to hit a button and have the boat stay exactly where it's currently at, like anchorless anchoring. There's so much you can do when every part of that boat is controlled by software.
Oh, that's really interesting. There's one more thing you wanted to say about maintenance. I have another question about software, but if you want to complete your maintenance point.
Maybe the tie a ribbon on the software part of this is atypical. The degree to which we can improve our boats over the air looks a lot more like what you would find in automotive compared to marine. That is an ability that, to my knowledge, no one else in the marine industry truly has.
Well, not just that. I mean, let's talk about software then. It's not just that you can improve it. It's just that a lot of it just exists. It doesn't even exist on other boats. This is
right.
Because electric sort of comes with digital, smart, connected, online. So I wanted to ask a couple of questions about that. Just like, what is, when I think about my parents' boat, it's all very manual, all very analog. Once you add that software layer, what are you programming? Like, what sort of things can this boat do that an analog boat couldn't? You know what I mean? I'm thinking of like my car will park itself and it'll beep if there's, if they'll beep if something else is close, all this kind of stuff. Like, is all that stuff being ported over to a boat?
A lot of it is, yes. It's being ported over to our boats, to be clear. You need the foundation, the hardware foundation, in order to enable this. Our boats are steer-by-wire and they're throttle-by-wire, and that enables a lot. We have pretty much every component speaking to each other over software, communicating via software, and that gives you so much potential that you could tap into. And then you need to pair that with a software team, with a firmware team, with teams that actually can take that potential and turn it into real features. Our team at ARC looks very different than your traditional marine company. We are a team of software engineers and electrical engineers, and those aren't the types of engineers that you tend to find at your traditional marine company today.
So then, like, I'm just thinking of software stuff now. So could I tell my boat, maintain a 25 mile an hour, or whatever the knots, whatever the equivalent is, and whatever the marine equivalent is. But like, instead of me eyeballing it and nudging the thruster this way and that, can you just tell it, go 25, adjust the thruster to maintain this steady speed?
Absolutely. I mean, that you're describing cruise control, and that was one of the very first things we built into the boat. And you can do that, but we take that many steps further. An example is you want to go wakeboard behind the boat. You hit one button and it fills the ballast system, deploys the control surfaces underneath the boat, sets the cruise control profile. In the future might queue up the song that you want, your equivalent of a walk-up song. You can do so much more when everything is controlled by the same software system. And then you've got a video feed that you can hit record on that's all integrated into the same platform. So I'll give you another example that really puts this into perspective. Another very basic feature that is lacking on most wake sport boats today is the ability to steer in reverse. Because these boats are...
Ugh, awful.
Right.
A miserable experience on a boat.
So we give you the ability to steer in reverse because we have two lateral thrusters on board paired with the main propeller. And the software intelligence to be able to talk to all of those at the same time.
Right.
And the sensors on board to be able to actually control for turning this. We can just do so much more here that even the basics aren't out of reach for the industry today because they're not wired up this way. They're not powered and controlled by software. And you can't update that software over the air.
Right. Now I'm thinking your other boat is a fishing boat. And my mind's racing about what does fishing software look like?
Right.
Can you have sensors that can show you underwater? Can it help you fish better? I have no idea what fishing software would look like, but
we're really limited only by creativity. And our goal coming into the market is get the right hardware in place and then start unlocking the potential of that hardware through software over the air over time. And I mean, if you were a customer of ours even 3 months ago, you have seen pretty dramatic improvements in the software system powering this boat. And, we're just getting started.
That's fun. That's pretty cool. Well, let's talk about sort of the elephant in the room, which is the other thing that comes up immediately when I toss this out on social media, which is that this thing, the Arc Sport, is close to $300,000 price-wise. So tell us, just to begin with, how is that comparable to other high-end wake sport boats? What is the sort of class price range?
It is directly competitive with other premium wake sport boats.
God, that's expensive as crap, though.
They are expensive. This industry has trended towards that more expensive area. And I'll tell you something interesting, or at least something I find interesting. In automotive, you have your Honda Civics and you have your Mercedes S-classes.
Right.
There's kind of this bimodal distribution of a bunch of these lower cost sedans and then a smaller bump when you get into the more premium end of sedans. Boating has that same sort of distribution in wake sports in particular, except that the premium class is the more popular one. Because if you think about this as this market segment, tends to be more of a luxury good, tends to cater to people that have houses on the water, houses on a lake.
Yeah.
And if you're going to enter that market and you've got a nice house on the lake, you're going to get the best boat out there. So these boats are certainly expensive, and our goal is to make a bunch of wake sport boats, but also use that to get into segments where the price of the boats are lower.
Well, this is my question. This is sort of, again, this is the classic Tesla strategy, right? You sort of create a foothold in the luxury market to establish that your hardware works and establish your brand name, and then work down and out to other segments, right? Is that sort of the basic idea?
Yes, definitely. Although, again, I would say you take wake sports, for example, our goal is not necessarily to just drive the price down as much as possible, because a lot of the interest and demand is for what's the best boat money can buy around this price point.
Right.
And so we'll continue to improve the boat at that price point, but not necessarily try to drive it down to half the cost it is today or something like that. There are other markets that are a lot more price sensitive where we will care a lot more about the price of the vessel and how do you get that down over time.
Well, I'm sort of curious about that question then, because it seems like if the battery again is the main thing, the biggest physical weight and also the biggest cost, I'm guessing. And so are you sort of to some extent at the mercy of battery prices, or are there other areas where you think you could substantially cut costs?
We will continue to cut costs as we scale because our components factor across every boat that we're building, whether the Arc Sport or the Arc Coast or any future products we introduce. And so we get economies of scale from that. We can also invest in tooling that allows us to manufacture the boats more efficiently as we scale. Having said that, yes, we are downstream of the automotive industry on some of our key components, including batteries. The good news there is...
Well, I mean, it's just not a bad, as you said earlier, that's not a bad place to be.
Right. It's actually quite a great place to be because for very little work on our side, what you tend to see is prices just fall over time because there's so much money and energy going into how do we produce cars for less money, and that's fueling all this R&D that we eventually get to take advantage of. So we like the position that we're in kind of downstream of that market.
So to some extent, you can reliably forecast that your costs will come down just because of that, just because you are lashed to the falling prices of batteries.
Yeah, holding all else equal, I would still expect our prices to come down. And again, we're stacking our own efforts on top of that when it comes to the efficiency of manufacturing the boats and the economies of scale we get on other components and all of that.
In terms of branching out, what's this I hear about tugboats? Tell me a little bit about that.
So
it's not on your product site, but it's in this LA Times article. So what's the deal there?
We have a core thesis at ARC that pretty much everything on the water should be rebuilt around an electric powertrain. On the consumer side, we've already talked at length about all the benefits you unlock by going electric. But on the commercial side, you look at why would somebody want that? It's because the biggest operating costs of a commercial vessel are fuel and maintenance. And if you want to go cut down on fuel costs, and if you want to go cut down on maintenance costs and increase reliability and uptime, boy, is going electric a good move.
Yes. That is the premise of this entire pod, you might say.
So that's kind of one of the core theses here. The kicker is that you still need to solve for range. You still need to solve for, how do you get battery packs that are big enough for...
Yeah, I mean, I would think all things being equal, as the boats get bigger and bigger, it just gets harder and harder. Because as you already say, even in a small boat, relatively small boat, you have a relatively giant battery pack. So I'm thinking big boats, don't the size of battery packs you need kind of get out of control pretty quickly. I would think big boats would be a much bigger challenge.
One of the things that we think about on larger boats is we want to rebuild them around electric powertrains, but that does not mean that they are purely battery electric. We're actually quite big believers in hybrid electric powertrains.
Interesting.
You kind of can view this almost like the grid source of energy. By going electric with cars, you push the problem of where does the energy come from to the grid. You could do that same sort of thing on boats. You could say, all right, we're going to go electric with this powertrain, which is a lot more efficient. And I'm going to come back to the efficiency piece in a second. It's a lot more efficient. And then you hook it up to some source of energy. Now, in the short term, that might be diesel generators. But in the medium term, that might be, some form of nuclear or any number of other ways to generate electricity in a more sustainable way. The efficiency that you get, though, is you look at your diesel motors. The efficiency is related to how much power they're putting out. And they're kind of primed to be most efficient when they're putting out a lot of power. So you look at tugboats, for example, they are most efficient when they're pushing or pulling on a larger vessel. However, a lot of these commercial vessels spend a lot of time at low speed, and they are just burning a bunch of fuel because they are running inefficiently at those loitering speeds.
Right. You can't scale energy use to power the way you can with the same precision as you can with a battery.
Right. So electric motors are perfectly happy to run at low speeds and have good efficiency across kind of all of that. What that means is that at those loitering speeds, you're actually, a lot more efficient and you're saving a bunch of fuel, even if you are backed up by diesel generators. Those diesel generators get to run at their optimum power from an efficiency perspective. So that's still an improvement. Even diesel electric hybrid is an improvement over pure diesel.
Or you could get fuel cells are in that conversation
Right.
too. I talked with a guy who's doing a fuel cell battery hybrid plane.
Right. So our focus is rebuild the vessels around that electric powertrain. And now you could kind of move the problem to, all right, great. Now what other source of energy do you plug into that? Then we also battery buffer them so that you could cover substantially all of your usage through that battery. So you look at tugboats again, we're talking about 7+ megawatt hour battery packs on these boats. And that allows you to run most of your operating profile just on batteries and then charge them back up. And you're now running that hybrid powertrain very infrequently, or that other source very infrequently, only as kind of a range extender.
Right. But you are making some tugboats, aren't you? I mean, I was a little surprised at that because when I was think like pulling a giant vessel is like the most power you could need. So that seems like the biggest battery, like of all the sort of mid-sized vessels to electrify, that intuitively struck me as like one of the hardest. It is, I mean, because towing a ship is a lot bigger of a task than towing a person on a wakeboard.
When you look at the hovercraft market, they are ideal for going electric because two of the biggest costs are fuel and maintenance. They run these short mission profiles where they won't actually cover that much distance. They will go out to collect and kind of escort a boat back in. They require a lot of torque. So you want, motors that can capable of a lot of torque. And they're in these ports that can install the infrastructure necessary to charge them. So I know that it might seem crazy, but when you just boil this down to what do operators care about their operating costs, they care about the fuel and maintenance costs, they care about uptime and reliability. And by going electric, they can, accomplish a lot of that. And oh, by the way, tugboats and hovercraft tend to be some of the worst polluters on the planet. They burn this diesel that's just
super gross.
Yeah, and it's not just about, again, emissions into the air. It's your black carbon, it's your sulfur oxides, it's your carbon oxides. There's a lot of pretty nasty stuff coming out of them, which is why they tend to be subject to some of the highest compliance scrutiny on emissions. And by going electric, you could jump way forward in terms of meeting those compliance needs that, like, you can kind of solve those once and for all.
So you have the one built. Are people buying those? Is that on the market, or is that just a demonstration?
You could think of that like our Tesla Roadster. It was a limited run of boats. They've sold out.
It's not going to be an ongoing.
It's not an ongoing project now.
So you've got the Sport, the wake sports boat, and you've got the fishing boat that's coming the coast next year. Can you tell us what are the next steps on the product map? Because as I was thinking about this, it is a little bit of a mind boggler. There's lots of different kinds of small boats. There are jet skis and other kinds of water vehicles. There are bigger boats. Like, you could go in a lot of different directions. Do you have a product map? And if so, can you give us a sneak peek?
We do have a product map, and unfortunately, I cannot give you a sneak peek. We have our hands full with ramping production of the Arc Sport to meet the incredible demand we're seeing there and getting the Arc Coast to market and into customer hands early next year. So that's where our focus is, both internally and externally. Our aspirations certainly don't stop there, but that's where the focus is today.
Okay, well, by way of taking us out, tell us a little bit about your R&D facility, because as we mentioned, as you mentioned earlier, a lot of these sort of various boat segments have become a bit commoditized, and so there's not big margins, and so there's not a lot of companies that do a lot of R&D. So you are distinguishing yourself in that way. What is the R&D facility, and what are you doing there?
Yeah, Arc is headquartered in Los Angeles, California. The reason that we're headquartered there is because it is an incredible hub for engineering talent, particularly on the hardware side.
Hey, before I forget, are your batteries also domestic? Like, how much of your supply chain is domestic?
We manufacture our battery packs out of our headquarters in Los Angeles.
I see. So these tariffs, for instance, you're not worried about.
We are not
tariff
immune.
environment.
If you view the purpose of those tariffs to encourage reshoring manufacturing, we are ahead of the curve there.
Right.
We are more vertically integrated and more domestic than many manufacturers are today. We are not immune to the tariffs. And again, especially as an electric vehicle company, there are critical supplies that come from overseas that will be impacted on. But we are in a pretty good spot as a company because of how much we have already vertically integrated, because of how much we already do domestically, and because we can be nimble as a company. We're pretty flexible and pretty fast moving, and so can adapt as the landscape for tariffs shifts.
And this R&D you're doing is, just sort of imagining like boat shapes, battery shapes, like the characteristics of vehicles moving through water. Like, am I warm?
Yeah, it's all of the above. So our facility in Los Angeles, it's 150,000 square feet.
Oh, wow.
All of our engineering, all of our production lives under one roof, which is incredibly important in terms of fast iteration and design loops. So we focus on battery R&D, we focus on manufacturing R&D, software R&D. It touches pretty much every discipline, and that's where work on the Arc Coast is underway. It's where our new commercial efforts are taking shape. It's all happening under one roof with everyone all sharing space, which means that knowledge sharing happens very rapidly.
Very cool. Very cool. All right. Well, this is as fascinating as I expected. I love hearing about things being electrified. So thank you so much for coming on and walking us through this. Super fascinating.
Absolutely. It was great talking to you. Thanks for having me.
Thank you for listening to Volts. It takes a village to make this podcast work. Shout out especially to my super producer, Kyle McDonald, who makes me and my guests sound smart every week. And it is all supported entirely by listeners like you. So if you value conversations like this, please consider joining our community of paid subscribers at volts.wtf, or leaving a nice review, or telling a friend about Volts, or all three. Thanks so much, and I'll see you next time.